This is a webinar on infrared remote hacking and automation. In this, I'll be going through these contents, basic introduction to what is the short-range infrared remote communication, basics of infrared communication, and how to decode any infrared remote controller you have. Then using that decoded infrared remote controller for controlling any device from a small device like LED to a AC devices, and then home automation session. So as an introduction, infrared remote controller are used in home appliances and computing devices because this is the cheapest solution for short range communication. And infrared technology is also not that complex to understand. So it is easy to understand, easy to hack, and easy to do DIY on infrared remote controllers. So this is the basics of infrared remote controllers. Commonly, we have seen controlling infrared remote controllers used in television, stereo players, music players, etc. So this is the simplest technology available for short-range communication and controlling. And most probably, there will be a transmitter-receiver pair. In this, here, the transmitter is the remote controller, and the receiver is the television and the control system related to that. So in every infrared remote control systems, there must be a transmitter receiver pair and an encoder decoder pair, which is actually to encode the hex code for each of the buttons in the remote controller, and the decoder is placed at the receiver end to receive and decode the code from the infrared remote controller. And the infrared remote controller transmit the code through infrared pulses through air. You can see the block diagram here. The top one is the block diagram of the transmitter, which will be having an encoder IC to encode a unique hexadecimal code, a unique hexadecimal code for each and every button on the remote controller. It's called the button array. Then whenever we press a button, the button sends that unique code, that may be a hexadecimal code, to the infrared LED. That LED transmits the pulses related to that code through air. And at the receiver end, it receives the infrared pulses using some kind of infrared receivers, semiconductor-based infrared receivers, and there will be a decoder circuit to decode that code related to that button pressed. Then there will be an embedded system-based decision-making circuit to do any action related to that button. This is the very basic and simplest explanation how IR remote controller system works. So next we have to go to the decoding part. Decoding part means we have to know what code is assigned to any remote controller. So for that we have to take a remote controller like that's shown in the picture, and we need an Arduino Uno board, a breadboard, some jumbo wires, and to receive a signal from the remote controller, we need a typical infrared receiver, which is the cheapest one is TSOP 1738 receiver. You can see in the picture, it's the simplest, it's the cheapest. It has a ground pin for connecting the ground, and VS pin connecting a 5-volt DC for its operation, and there will be out pin, which will be outputting the signal from the remote controller. So this is the circuit diagram setup for the decode circuit. You can see Arduino Uno, whose VCC, whose ground and 5-volt is connected to ground and 5-volt of the TSOP infrared receiver, and the output of that TSOP infrared receiver connected to pin number 11 of the Arduino. The coding is done in Arduino IDE. You can see that you can download that code from the electronicforyou.com website. I can share the link at the end of the presentation. And the infrared decoding is conducted with the support of a dedicated infrared library. That too you can download from electronicforyou.com website. Now what we have to do is, after setting up the circuit, we have to point the remote controller we have to the infrared receiver in the circuit shown in the circuit, the black one, the 3-pin in TSOP 1738. But whenever press a button, the Arduino serial monitor, we have to open that Arduino serial monitor. Whenever we press a button, the serial monitor will be displaying the code, hex code related to that button as shown in the figure. Here, the code is 1FE807F. So after that, this is the remote controller I used. Then we have to record the button name and the code related to it for using for the using. Then now we have to control a device using this particular remote controller. So now we have all the buttons code relate all the codes hex codes related to each and every button shown in the figure. For the play pause button, the code is 0x1FE50AF. Now we have to change a little bit changes in the code to connect an LED to the Arduino board. We have connected the LED to the 13th IO pin of the Arduino and coded, and the code also you can see on the Electronic for You website. So now we have the full setup for controlling an LED using the remote controller. So until now we have controlled a single LED using the remote controller. Now we have to go to the home automation part. So in home automation there are two parts. It means a receiver part to receive the signal from as we shown, receive the signal from the remote controller, and the next part of the circuit is a high voltage, means to control AC devices there will be a high voltage part that deals with 230 volt or etc. So to couple these two circuits, the low voltage signal circuit and high voltage AC circuit, what we need is a relay circuit. Either you can purchase a relay as shown in the slide, or you can yourself design and fabricate a relay circuit like this. So the relay circuit is nothing but it is having a 3 input part, a 3 input pin, 2 output pin. In the 3 input pin are VCC and ground and input. The VCC ground are for the operation, so we can connect VCC and ground for the 5 volt and ground of the Arduino board. And the input to the as shown here, the green wire is the input of the relay circuit. So the green wire can be connected to pin number 13 of the Arduino. So here also the code also can be downloaded from the fy.com website. After that, you can connect the AC devices to the J1 port of the relay circuit as shown. Or if you are purchasing a relay, you can directly connect to the port connection of the relay circuit as shown in the figure. The blue one is the port connection of the relay circuit. So as you control the LED using remote controller, the same two buttons can be used to control the AC devices also. So I would like to conclude with this complete circuitry that I published in the January EFY magazine last January. So this is a complete circuitry. I replaced the Arduino Uno with Arduino Pro Mini, and all the complete part of the circuit, including the Arduino Pro Mini and the relay circuit and the infrared receiver, everything is integrated into a single PCB, and you can directly download the PCB layout diagram and the project code from the efy.com website. So this is the link. Through this link, or you can simply search on Google for infrared remote hacking and home automation and download the code from code from electronicsforyou-magazine.com. I think this is the end of the session. How to find the code for the remote? You can find the code. You can simply search infrared remote hacking and home automation. You can find the code and the entire documentation at the electronicforyou.com website. Why a 7-byte code for a button press? Yeah, the 7-byte code is actually called the hexadecimal coding system. Hexadecimal coding system is invented to replace the binary coding system, because hexadecimal coding system has 16 bases. So we can include, we can accommodate a huge number of codes in that. Such as some remote controllers will be having more than 50 buttons. So with that 7-byte coding system, we can accommodate that much codes. Electric switch automation need which board? I think you can use any simple Arduino boards from Arduino Uno, Arduino Pro Mini, and even Arduino Mega. If you are you are wishing to control a single device, you can use a small Arduino Uno. If you have more than 5 or more than 6 devices to control, you can go for Arduino Mega. Vishnu Dhanawat, using relay module, can we know the status of LEDs on and off? Yeah, sure. You can accommodate small LED on the relay itself, so that you can check the status of the relay whether it is on or off. What frequency do IR remote use? There is no major frequencies for infrared remotes. That changes. That depends on the manufacturer. Actually, there is no fixed frequency for. There's actually a range of frequencies for operating infrared communication. Yeah. Yeah. When you convert it to binary, it's 28 bits, Mr. Shashidharan. Yeah, it is 7 bytes in case of when you represent it as a hex code. But in binary, to convert into binary, it will be much larger, 28-bit width. Any more questions from the audience? I think it's time.